So now let's do an example with numbers. So we have the same situation that we saw earlier with a stone that's hanging from two cords, one that's horizontal and one that's at an angle. In this case, we've been given that the angle is 30 degrees and that the mass of the stone is 0.5 kilograms. And the question is to find T1 and T2. So let's start using our goal system. We're going to gather information. So one thing that we know is that the mass is equal to 0.5 kilograms. We know that gravity is going to be equal to 9.8 meters per second squared. This gravity is pointing downward, so that's negative. So that means that the force due to gravity is equal to mg. And I'm going to allow the negative sign to just be in this g here. So that's what's going to give us that the gravity is pointing downward. We also know that from before that the sum of the forces in the y direction has to equal 0 because the stone is not accelerating. And so that means that we have mg plus t1 in the y direction has to equal 0. We also know that the sum of the forces in the x direction has to equal 0. So that means that we know that t1x plus t2x, that has to equal 0. And we do know this angle of this 30 degrees here. In the next section, we are going to, of the goal, we're going to organize our approach. Okay, so now what we need to do in our organizing approach is we've already got this nicely laid out, and that's what we're going to use. But we do need to figure out how what T1y is, T1x, and T2x. We know that in this case T2y equals 0, so we didn't include it in there originally. So the way we want to do this, let's draw a picture and break down the T1 component, tension force into T1y and T1x. We have an angle here of 30 degrees. And now we can figure out T1y is going to be equal to T1 times, we have to think if it's the sine or the cosine. Sine is some old opposite over hypotenuse, so it's not going to be sine, it's going to be cosine. And that's cosine of 30 degrees. We can do T1x, which is equal to T1 sine of 30 degrees. Now, because the reason why these are flipped from what they normally are, normally we think about y as being sine. You can't just memorize that. You really do have to use trigonometry each time, and that's because they gave us a different angle. So if they had given us this angle over here, which as theta, then we would be able to use that normally. But in actuality, they gave us this other angle phi. So we're going to use that angle to figure this out. Okay, so now putting all of this together, we can do our analyze our results. Okay, so for analyze, we have, again, 0 is equal to mg plus t1y. And so I'm going to analyze in the y direction first. So that's equal to minus, let's actually rearrange that equation first. Go eraser. Okay, so let's actually say minus mg plus t1y. Oh no, sorry, equals t1y. Should I do the eraser again? It's so fun. Okay, so I'll do that. Okay, and then we know that t1y is equal to t1 times, from before we had it was the cosine of theta. And so we know that, and we know that mg, so we can solve this for t1, which is one of the things that we're looking for. t1 is equal to minus mg divided by the cosine of that angle theta. And now I'm going to plug in my numbers at the very end. Minus 0.5 kilograms times negative 9.8 meters per second squared divided by cosine of 30 degrees. We plug that all into our calculator, and we get that T1 is 5.7 newtons. All right, now, so this was the y direction. We can do the x direction separately. And in the x direction, we know that 0 is equal to T1 in the x direction plus T2 in the x direction, which is equal to just T2. So that gives us that negative T1x is equal to T2. Right? And so basically I just said that, all of T2 is in the x direction, so I'll just call that T2. All right, so negative T1x is minus 5.7 newtons, and the x direction was sine times sine of 30 degrees. So that's what we said on the previous page. That's equal to T2. So that means that T2 is equal to negative, I just plug this in my calculator, 2.9 newtons. Okay, just box my answers here so that I can know where my answers are, and that's the solution to the problem. Our last step is learning from what you did, and what we can see here again is that the x and the y component addition is the easiest way to do these problems. The sum of the forces was equal to 0, and that's what allowed us to solve for T1y and then ultimately T2. The other thing I want to point out is that given our coordinate frame, which we always make where y is positive going up and x is y going to the right, we can see that T2 is a negative number, and that makes sense because T2 is pointing in this direction. T1 are both the x and y components are positive, and FG was actually a negative. And so all of this together makes sense, and we can see that we've learned how to we've done an example here where we've done the component form of the sum of the forces.